Welcome back, learners, to this lecture series of strength of material, as we have discussed about the topics which we will be discussing throughout this subject in our earlier lecture. So now, without wasting a lot of time, let us start to the first topic, where our first topic will be properties of material. Properties of material. Okay. So with that, let us start with the very first definition of our topic, and that is strength of material. What actually is the strength of material? Okay, so let me write it here only. Strength of material, as we can see that strength of material is a branch of science which deals with the influence of loading. It is a branch of science which deals with the influence of loading on the deformable bodies. Okay, based upon Hooke's law. So this is the definition which we can see. So let us see what are the new terms which arises in this definition, and we'll keep on countering those terms, and in this manner we will be completing the subject. Okay, so here which we can see that strength of material, basically it is a branch of science which deals with the influence of loading on which kind of bodies? On deformable bodies. Okay, earlier in our engineering days, in our first year, which we had a subject which was about engineering mechanics. In the engineering mechanics, we all have observed that most of the studies which were involved in engineering mechanics were related to rigid bodies, not of the deformable bodies. But we all know that in practical day-to-day situation, none of the body is rigid. There is no such body which is perfectly a rigid body. Most of the bodies are deformable. Most of the bodies show some kind of deformation. Okay, so in strength of material, what we do here, we actually discuss about the influence of loading. Like if we apply a load on a deformable body, what kind of analysis which we can obtain from that application of load. In this entire subject, we'll be discussing about the forces, we'll be analyzing about the forces, the stresses, the strains, we'll be analyzing about the relations in between stress and strains, we'll be discussing about the various type of elastic properties of the body. Okay, so first of all, let us begin with the definition itself, and it's quite simple. It is the study of influence of load on a deformable body. So here we get two new terms. The first one is deformable bodies, and the second one is Hooke's law. And we'll be discussing both of this in our next stage. Okay, so there comes a term known as deformable body, and the other one which I was comparing with was the rigid body. So first of all, let us clear the definition or the difference in between deformable bodies and rigid bodies. That actually, I think it's very simple. Like I'm writing here, it is a rigid body, and here let us write a deformable body. So what is the difference? It's quite simple. Like it shows a rigid body does not show any kind of deformation. It does not show any kind of changes in the length, in the volume. Alright, so we can say that no change is observed in the dimensions of this body. On the application of force. Alright, on the application of force. And if we compare a rigid body with a deformable body, what do we see here? It is quite clear with the name itself that there are some visible deformations. In the body. But why do we see those deformations? Because we have applied some force. So we can say that on the application of force. So this is the basic difference between a rigid body and a deformable body. Okay. So the definition was to study the influence of loading on which kind of body? On the deformable bodies. And on the next term is this. What is this? This is Hooke's law. Okay. So let us discuss about this next term also. Hooke's law. Hooke's law. What does it signify? Hooke has performed a few of the experiments on various engineering bodies, and with the help of that experiment only, he said that there exists a relationship between stress and strain. Okay, and as per his experiments, experiments which he performed in the laboratories, he said that the stress is directly proportional to strain. Like if we try to strain the body, what comes in the action, what comes in the reaction? It comes stress. Alright. So with further discussions, we will be getting more idea about the stress and strain. So what actually he wants to say is this. Suppose that we have a body, and suppose it is fixed at this end, and we try to apply some pull, or we try to apply some axial pull or force on this body. What will happen? We will see that since it is a deformable body, originally, let us suppose that length of the body was L. Now, what we will observe that there is some sort of elongation in this body, and that elongation is just because of this application of force. Alright. So, this observation can be justified in such a way that whenever we apply a force on a particular body, if the body is deformable body, it will show some sort of strain. It will show some sort of change in the dimensions of the body. That change will depend upon the nature of the applicable force. So in this case, as we can see, it is very clear that the force is tensile nature, and due to the tensile nature of force, the length of the body actually changes and it actually increases. So this is known as the strain, the change in length with respect to the original length. Right? So whenever the body is being strained, either with the help of compressive force or with the help of axial force or with the help of bending or shear forces also, there comes an inherent resistance in the body. And that inherent resistance is just because of the molecular arrangements of that body, which is also known as the stress. So we can say that strain is the cause of stress. Okay. So first of all, strain is being applied by the application of force. And in result of that, in response of that, the body tries to resist that deformation. And that resistance, that internal resistance which the body actually applies, is known as stress. So with this, if we write this stress with this symbol, we can say that stress is directly proportional to strain. These are the universal symbols which we will be using throughout the subject. Okay, so stress is directly proportional to strain, and if we remove this limit of proportionality, what do we get? We get Young's modulus of elasticity. What is this? This is Young's modulus of elasticity. With the help of this parameter, elasticity, we can compare between various bodies. We can compare between, let us say, steel and aluminium. We can compare between steel and rubber. So, what does this elasticity signifies? Elasticity is actually, let us go to the next slide. Okay, what is this elasticity? So, we can say that elasticity is something which can be explained as whenever we apply force on a body, it begins to deform. Okay, and on the removal of that force, the body tries to regain its original position. Or original shape. So the property by which the body tries to regain its original shape is known as elasticity. This property which helps a body to get back to its initial shape is known as elasticity. Okay, let me write it here. It's known as elasticity. Okay, so here we come to know about the definition of elasticity. So there is a general perception, all right, which goes through among the students. Like if I ask you a question, compare, I will give you two materials and you'll have to compare between them and you'll have to say which one is more elastic. And the material is, the first one is steel and the second one is rubber. So try to analyze and tell me which one of these two material is more elastic. Either it is steel or rubber. Few of you will say that steel is more elastic and few of you will say that rubber is more elastic. But we can compare this with the help of Young's modulus of elasticity, which says that Young's modulus of elasticity is greater than Young's modulus of elasticity of rubber. Young's modulus of elasticity of steel is greater than Young's modulus of elasticity of rubber. Therefore, we can say that steel is more elastic than rubber. Okay, we can say that steel is more elastic than rubber. We can also understand this difference, or we can also take this with a simple example or a simple experiment if we try to perform it. Okay, suppose we have a steel bar, and if we apply force P, alright, there will be a slight change in the length of this bar. It will elongate just because of the strain. And if we remove this force P, what happens is the steel bar will try to regain its original position, right? It will go from this position to this position. Suppose the time taken for this is T1. If we try to do the same thing with rubber, since rubber is less plastic in nature, it is more of a ductile, so it shows very less elastic deformation. So if we try to apply force, some sort of elongation will be observed in rubber also. Okay. But if we remove the force, rubber will also try to regain its original position. And from here to here, let us say the time taken by rubber is delta T2. Okay. This is the case of steel and this is the case of rubber. So what we see that delta T1 is less than delta T2. And with the help of this experiment also, we can say that steel is more elastic than rubber, because after the application, after the removal of this force, steel tries to get to its original position much quicker than that of the rubber. Okay. Alright. So that was the, let us get back to our previous slides. Okay. So here we came to know about the deformable bodies, and also we came to know about the Hooke's law, which shows that there is some relationship in between the stress and the strain of various bodies. Okay. Now let us continue our discussion. Okay. So there is a thing known as engineering science. Alright. So this engineering science can be classified into three different groups. Okay. The first one is solid mechanics. The second one is fluid mechanics. And the third one is properties of material. Properties of materials. Okay. And in solid mechanics only, there are two different subtopics. The first one is engineering mechanics. And the second one is strength of material. So, okay. So in solid mechanics, it can be classified into two different subtopics. The first one is engineering mechanics and the second one is strength of material. What is the basic difference between these two? Okay. In engineering mechanics, we deal with the rigid bodies. Which kind of bodies do we deal with? We deal with the rigid bodies. Okay. On the contrary, in strength of material, we deal with the deformable bodies. We deal with the deformable body. Okay. And also that study is done with the help of Hooke's law. So we'll be keeping in knowledge about Hooke's law, we'll be keeping in knowledge about this deformable bodies, and we'll have the knowledge of rigid body and the deformable bodies. So in our earlier days, we had discussed about this engineering mechanics in our college days. So most of the topics which were covered in the engineering mechanics were only discussed about the rigid bodies. Okay. But here, in case of strength of material, we'll be discussing about the deformable bodies also. Okay. So let us see a slight difference, that how does a rigid body differs from a deformable body. Suppose this is a rigid body, and let us suppose this is a deformable body. Okay, and suppose we apply forces on this body. In what manner? Let us see. Suppose we have applied this and this force F1 and F2, and similarly we had applied the force F1 and F2 on the deformable body. With this basic diagram, we can come to know that there is a difference between rigid bodies and deformable bodies. Okay, let me say that F1 is equals to 10 Newton and F2 is equals to 5 Newton. F1 is equals to 10, F2 is equals to 5. F1 is equals to 10 and F2 is equals to 5. So if we try to analyze that what actually happens in the rigid body, we will see that the forces, the net force which will act on this rigid body will be this force only, that is F is equals to 5 Newton in this direction. And with this force, the rigid body will move from position 1 to some another position 2. Okay, so this is how the rigid body behaves, but the shape of the rigid body will remain same. In this diagram there is slight difference in the shape, but the shape remains same. On the other hand, if we try to discuss about the deformable bodies, what actually happens is the resultant force which acts on the deformable body will be 5 Newton only. Alright, but apart from this, what we observe is this, that this deformable body is also being compressed with a force of 5 Newton. Like the force of 5 Newton which acts in the left direction, and here the force of 5 Newton which acts in the right direction. This force can be split into two forces, 5 Newtons and 5 Newtons. Suppose this part is counteracting this part and this part is additional. So this will act as a net force, and the net force, what will it do? It will change the position of the body. It will go from position 1 to position 2. But this 5 Newton extra force will deform the body. This will try to deform the body. So suppose initially the length of the body was L, now the length will be L dash. Okay. So what have we observed? That this extra force 5 Newton will try to deform the body. Okay, because it will act as a compressive force. So this is the difference between a rigid body and a deformable body. Okay. Alright. So let us discuss few of the points about strain and the stress. So as I had told you that whenever we try to apply a force on a body, what actually happens is the body tries to deform, and that deformation is known as strain. Okay. So we can simply say that the deformation which occurs in the body due to the application of external force, due to the application of external force is known as strain. So if we have a bar and we try to pull it, initially the length of the bar is L, but after we apply this force, what will happen? The length will be increased and it will become, let's say, L plus delta L. So what will be our strain? Our strain will be change in length upon original length. So this is the definition of strain. Okay, the deformation which occurs in the body due to the external force is known as the strain, and numerically it can be explained as strain is change in length we have to keep this point in our mind, that this is the change in length with respect to the original length. Okay, all right. So let us continue our discussion further. Few more points which we will be discussing about strain. The first one is this, that we can say that strain is a cause of stress. Okay, we have discussed it also, that whenever we try to strain the body, whenever we try to deform the body, there will be some internal resistance offered by the body against that deformation, and that internal resistance is known as stress. So we can say that strain is the cause, or strain is the reason of stress. Stress is not the reason of strain. It's because of the strain only that the body is being stressed, not because of the stress which we apply on the body, which results in the strain. So try to keep this difference very clear. Okay. So we can also say that strain is a fundamental quantity, right? Whereas stress is a derived quantity. Stress is a derived quantity. Okay, because this is stress is the internal resistance which occurs in order to resist the deformation. Okay, now let us have the definition of stress. As we have discussed it, it can be defined as stress can be defined as the internal resistance can be defined as the internal resistance which is offered by the body in order to resist the deformation. Okay. So stress is actually a derived quantity, it is not a fundamental quantity. So let us try to understand this with a basic diagram. Suppose this is a bar subjected to a load P. So if we try to take the cross section, would actually of width dx. Suppose we have taken out a cross section of width dx. What we will observe is this, that this portion, this cross sectional portion dx of this bar is subjected to this force, this external force P. And if we try to explain this stress numerically, what it is the force over that area. Okay, force by area. Although by the definition we can say that it is the internal resistance which is offered by the body in order to resist the deformation. Okay, all right. Now let us continue our discussion. So we had discussed about the stress, we had discussed about the strain. Now we will be discussing about the stress strain relationship, and which can be simply be obtained with the help of this stress strain diagram. And the stress strain diagram is being performed majorly over a mild steel specimen. Okay, so this is a mild steel bar, this portion, and this is a universal testing machine, UTM. As we can see that our area of observation is this portion, BC. So whenever we use this mild steel specimen, what we do is we try to reduce the area at a particular region, so that if the forces are applied in this bar with the help of this UTM machine, either tensile force or compressive force, the stress concentration which is being observed in the BC portion should be more than the stress concentration in the upper and the lower portions. Okay, here in this BC portion the stress concentration will be high, and if this bar is about to fail, the failure will only be observed in this BC portion only. Okay, so let us start the discussion of this stress strain diagram. Basically, it somewhat goes like this. Okay, alright, so that's how we observe a stress strain diagram, in which this axis resembles the stress and this axis resembles the strain. Okay, so I'll be mentioning few of the points here. Let's say this is point A, let's say this is point B. Okay, this topmost, let us say it is point C, this is point D, let's say this is point E, this point, let's say it is F, and this point, suppose it is G. Now we will be discussing about these critical points which we observe in a stress strain curve of mild steel. What is it? This is the stress strain curve of mild steel. I can write it here only. Stress strain curve of mild steel. One very popular question comes in various competitive exams regarding this, that why do we always prefer mild steel in order to plot this stress strain diagram? So the answer to that question is that in mild steel we can observe or we can witness maximum point which we can study, which we have to study. Like if we use another type of steel, like if we use H5SD steel, or if we use aluminium or any other material, all of these points relate respectively A, B, C, D, E, F, G, all of these points are not visible in any other material. So mild steel is that much useful because we can study most of the points, most of the critical points in mild steel only. Alright, so now let us start discussing each and every point. Let's say what are these points and what they actually stands for. So I'll be naming this and then we'll be discussing every point. The first point is point A, which is known as proportionality limit. Right? Proportionality limit. In this, we can say that stress is somewhat proportional to strain. Okay, stress is proportional to strain in this region. In what region? OA region. Where is O? Let me mark it. Let's say this is point O. So in this region, in OA region, the stress is proportional to strain. Like if we try to increase the stress, if we try to reduce the stress, what happens is the rate remains constant. What is rate? This is slope. Rate is the slope. The slope of this stress strain curve remains constant in this region OA, and therefore we say that OA region is the limit of proportionality. Okay. Now the next point. It is point B, which is also known as elastic limit point. Elastic limit point. Now the question arises, what is elastic limit point? Right? So we had already done the discussion about the elastic limit or the elasticity. So what is elasticity? It is the property here. Look at, see at this point, see this underlined point. It is the property which helps the body to get back to its initial shape on the removal of force. So what is the elastic limit point? It can be say that after the moment we reach this point, if we try to remove the force, what happens? The body again try to regain its original position, and it successfully does that. But if we try to increase the stress beyond this point, like if we reach this point C, or if we further reach to point D, then on the removal of force at that point, the body won't be recovering its entire initial position. There will be some sort of yielding in the body. Okay, and therefore we can say that this point B is known as elastic limit point. And by definition, we can say that up to this, the body can regain its original shape. Okay, original shape. This is very important point. Now, our next point of concern is point C, which is not very important for the engineering aspect, because this is a very transient phase, that it doesn't last for very long. It happens, it occurs for a very few seconds, for very microsecond we can say. This is upper yield point, okay, known as upper yield point. Okay, can be defined as the point where the yielding begins. Where the yielding begins. But it is not a very relevant point. Not relevant, we can say. It is very transient in nature. It lasts for very small span of time. And in most of the materials, except the mild steel, we do not obtain this. We cannot obtain this point experimentally. It's very hard to determine the upper yield point of the material. Even in mild steel also, in order to determine the upper yield point, we have to do a lot of experiments, a lot of reiterations. Okay, so it is of no use. Our most important point is this lower yield point. Okay, lower yield point. By definition, lower yield point is the point where we can say that the force which is required with the help of this lower yield point, we can say that the force which is required in order to maintain the yielding, in order to initiate the yielding, or in order to maintain the yielding, we can see this point, the lower yield point, at this position. Okay, so this is the force which is required in order to maintain the yielding of a body. Okay, so we can simply write it by the definition. It is the actual yield point. Sorry. It is the actual yield point. If you are concerned, if you are asked about which yield point should we take, so the answer would be the lower yield point. Okay, because the upper yield point is like it is transient in nature and it is very hard to determine. Therefore, we only study about the lower yield point. So we also say that it is the actual yield point. Okay, which and what does this point explains? This point explains about the load required to maintain the yield in its true characteristic. Of material. So the lower yield point, how can we define it? Lower yield point is the actual yield point which explains about the load required in order to maintain the proper yield in its true characteristics. Now what is this true characteristics? Like yielding is something which we use in order to design our material. Okay, suppose we have to design a building, suppose we have to design a bridge or something else. So what is the point of our concern? What should be our point of concern? Our point of concern should be the yield point, and out of this we can easily obtain two yield points in mild steel, the upper yield point and the lower yield point. But which one is given more preference? The lower yield point. Okay, so we can say that the lower yield point tells us about the load which we apply and get the yielding. So it gives us the upper limit of the load which should not be exceeded, because if we exceed that load, what we will observe after the application, after the removal of the force, after the removal of that load, the body is not going to regain its original position, and that situation will be known as yielding. So we can say that with the help of lower yielding point only, we can put an upper cap on the application of load if we are about to avoid the yielding of the material. Okay, so in this diagram we can observe that there is a difference in between point C and point D. Okay, in the stresses, as point C is carrying higher amount of stress as compared to point D. Okay, so why does it happens? The difference in between point C and point D, we can say that the difference in between C and D occurs because both of these points are the yield points, but one is the upper yield point and the second one is the lower yield point. So why does this difference in the stress occurs? This occurs because of the molecular slippage of carbon atom, because of the molecular slippage of carbon atom. As we all know that in steel, what are the major constituents of steel? We know that steel is built up of iron and some sort of carbon is also added. With the varying percentage of carbon, the strength, the ductility, the elasticity, malleability, all of these properties are hampered. Alright, so if we use more carbon, we will get high strength steel. If we use less carbon, we will get low strength steel. So it's just because of the carbon atoms only, and it's just because of the slippage, or we can say that rearrangements of these carbon atoms, that we can simply observe there is a difference in between the stresses of point C and point D. That is the upper yield point and the lower yield point respectively. Now the next point of concern is point D to E. Okay, this one, point D to point E. This is also known as yield plateau, right? So let us write it here, DE. What is it? This is yield plateau. Why do we say it yield plateau? Because if you see in this diagram clearly, you can say that with no increment in the stress, there is a lot of strain available. Okay. So at this stage, at the point D, we can say that steel is showing a bit of plastic behavior. Okay. So here we can say that strain is predominant. Alright, strain is predominant. Or we can say that a large amount of strain is visible for negligible stress. Okay, for negligible stress increment. Alright, so this was the yield plateau, this portion. Now we have one more point, that is F. Okay, so first of all let us discuss this point F. We can say that it is the ultimate point. So why do we say it as ultimate point? Because at this point the material can take maximum amount of stress. At this point the mild steel can take maximum amount of stress. Okay, so we can say simply maximum amount of stress can be taken till F. Okay, till F. Now let us discuss this zone, this EF zone. Okay, this EF zone. Let me shade it like this. So this EF zone is known as strain hardening zone. Okay, strain hardening zone. So we can write it here also, EF. So what happens actually, that when the material reaches at its point E, some sort of plastic arrangement is observed, and due to that plastic arrangement, now the strength capacity of the material increases, or we can say the load carrying capacity of the material suddenly increases. Okay, so this is called as strain hardening zone. Strain hardening zone. Okay, why does it happen? It happens due to the plastic rearrangement. Due to the plastic rearrangement, the load carrying capacity increases. Okay, due to the plastic rearrangement, the load carrying capacity increases. Now the next point of concern is point G. It is failure point. Okay, we call it as failure point. Here the material finally cracks in two parts. Okay, here the material finally cracks in two parts. Now we can see this from the diagram also. This zone, this FG zone. Okay, so another point of discussion may be this FG zone. This is nothing but zone of necking. Zone of necking. Okay. In this, we can say neck formation is visible. Neck formation is visible. Okay. How does it happen? You can see this from the previous diagram. This diagram, we had discussed it earlier. That BC portion, in the BC portion, the cross-sectional area is kept slightly less. Okay, and due to this, what happens? The stress concentration takes place. Now, all of the analysis is considered to be happening in this BC portion only. So, what happens is, initially, the BC portion remains like this. This is B, this is C. After some time, after reaching point F, what happens? The area starts reducing. Okay, this happens with BC portion. On increasing further stress, what happens? It almost forms a cup and cone type of structure. Okay, and finally, when it reaches to point G, what happens? It is splits into two parts in some sort of cup and cone shape. Okay, and that's why we refer this FG zone as zone of necking. Alright, so with this, we'll be concluding today's lecture. Alright, and hope you like this video, and you'll be directed towards other videos also in this lecture series. We'll be discussing all of the topics of strength of material, all of the necessary topics, and we'll be discussing some numerical aspects also throughout the conceptual explanations. And once we are done with this subject, we'll take some other sessions in which we will be covering the interview based important questions, and apart from that, the numericals which are frequently asked in the exams. We'll take one more lecture over that. So till then, take care, and thank you so much.